Section 6.4, we talk about how we can prove triangles are similar. And the first way to do that is by angle-angle similarity. So we zoom in postulate 22. Shows what angle-angle similarity is. It says if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So you can see that angle K and angle Y are both congruent. And then angle J has 2 marks, and so does angle X. So we have two angles in a triangle JKL that are congruent to two angles in triangle XYZ. So therefore, by angle-angle similarity, the two triangles are similar. Okay, and what that means is if you took the smaller triangle and just stretched it out, made it bigger, it would line up perfectly with that bigger triangle. So in example 1, it says, determine whether the triangles are similar. If they are, write a similarity statement and explain your reasoning. So if we look at these two triangles, we can see that angle E is 90 degrees, and so is angle B. So I'm going to say angle E is congruent to angle B. Right, and now we're missing a couple angles. So if you look at this bigger triangle, we have a 90-degree angle and a 22-degree angle. So if we think back with triangles, the three angles of a triangle will always add up to 180. So we would know that angle F plus 90 degrees plus 22 degrees will equal 180 degrees. So that means angle F plus 112 degrees equals 180 degrees. And we will solve this for angle F. How do you cancel plus 112? We do the inverse, which is minus 112. So angle F equals 68 degrees. And now you can see that we have an angle in the bigger triangle, that's 68, and an angle in the smaller triangle is 68. So we know that angle F is congruent to angle C. Okay, so are they similar triangles? Yes. And it says to write a similarity statement. So how I would write the similarity statement is I would say, all right, well, triangle ABC is how I would name the first triangle, A, then B, then C. So when you name the second triangle, you got to match up the corresponding parts. So what angle matches up with angle A? And you can see angle A and angle D match up. So D would have to come first. Okay, and then what matches up with B? You can see angle B is congruent to E, so E would come second, and C matches up with F, so F would come last. So are they similar? Yes. The similarity statement is triangle ABC is similar to triangle DEF. And by the way, this green symbol, well now it's green in the middle, is the similarity symbol. It means they're similar to. And how do we know they're similar? By angle-angle similarity. That's our reasoning. So in the checkpoint it says, determine whether the triangles are similar. If yes, write a similarity statement. So in number 1, we have a 78-degree angle in each of them. And we got to find out what the missing angles are. So to find out angle Q, we would do 180 minus the other two angles. So minus 71, minus 78. So 180 minus 71 minus 78 is 31 degrees. So that means angle Q is 31 degrees. So we can see that we also have two angles that are 31 degrees. So are they similar triangles? Yes. Angle-angle similarity. And then we have to name them. Triangle QRP is how I'm going to name the first one, is similar to triangle. So what matches up with Q? Q is 31, and so is G. What matches up with R? R is 78, and so is F. So it would be G, F, H. So yes, they're similar, and the reason is angle similarity, and triangle QRP is similar to GFH. And number 2. So we have to find the missing angles. So to find angle F, we would do 180 minus angle G and angle H. So minus 110 minus 27. 180 minus 110 minus 27 is 43 degrees. Okay, and then if we wanted to find angle Q, we would do 180 minus 53 minus 27. 180 minus 53 minus 27 is 100. So if you look, we have a 27 degree angle in each triangle, but that's all we have. The other angles are not congruent. So are these triangles similar? No, because, let's put not similar, because we only know they have one pair of congruent angles, not two. In example 2, it says, show that the triangles are similar. Explain the two triangles are similar. Part A, triangle RTV and RQS. So we're trying to show that they are similar. If you look at the two triangles, we have the red triangle, which is RTV, and then this bigger blue triangle, which is RQS. So in each triangle, we have a 49 degree angle. So if we actually separate these into triangle RTV and the bigger triangle, which is RQS, they each have a 49 degree angle, and they each have angle R, which is the same angle in both of them. So angle T is congruent to angle Q, and angle R is congruent to angle R. So are they similar? Yes, by angle similarity. And part B is triangle LMN similar to triangle NMP. We have to show why. Well, we know that angle L is congruent to angle N based on the picture. And then what we have here is parallel lines that are cut by a transversal. And if you look, and actually I gotta change my line here. I drew the wrong one. I'm gonna do this line here. They're cut by a transversal, and if you look, we have corresponding angles. Right? I'm gonna call this angle 1 and this one angle 2. So we would say angle 1 is congruent to angle 2, and the reason why is from earlier this year. Parallel lines means corresponding angles are congruent. So that's how we got that. So technically we have two angles in each, angle L and angle N, and then angle 1 and angle 2. So this would be angle similarity as well. And in the checkpoint it says, show that triangle BCD is similar to triangle EFD. So we have a right angle in each triangle, and then in this one, we change colors, we actually have these vertical angles. And I'll call that angle 1 and angle 2 again. So we would say angle 1 is congruent to angle 2 because vertical angles are congruent. So we have vertical angles again right here, angle 1 and angle 2. So these triangles are similar by angle, angle, similarity. All right. And in example 3, it says a lifeguard is standing beside the lifeguard chair on a beach. The lifeguard is 6 feet 4 inches tall and casts a shadow that is 48 inches long. The chair casts a shadow that is 6 feet long. How tall is the chair? So what we have here is two similar triangles. I'm going to zoom in on this. They both are right angles, and they both have the same angle from the sun. So these are similar triangles. We're going to set up a proportion, right? And we're going to do chair over person. Okay, so what we do know is that the shadow of the chair is 6 feet, and we know that the shadow of the person is 48 inches. Okay, 6 feet and 48 inches. Okay, and actually I'm going to write this in inches. So I'm going to put up here actually 6 feet is equal to 72 inches. And let me change this. Oops, I don't know if I can. Yeah, I'm going to go back and change it now. Instead of saying 6 feet, this chair is really 72 inches for the shadow, and the person is 48 inches. Okay, so we did the shadow length. And then the height of the person is 6'4", and the height of the chair is X. So X will go on top. I'm going to change 6'4" into inches. So 6 feet is 72 inches. So 72 inches plus 4 inches is 76 inches. Okay, so he is 76 inches tall. So from here, we cross multiply and solve. So you'll get 48 times x equals 72 times 76. So 48x equals 72 times 76 is 5,472. Divide by 48. X equals 114 inches. So how tall is the chair? It's 114 inches, and we got that by setting up a proportion. And the checkpoint says, in example 3, how long is the shadow of a person who is 4 feet 9 inches tall? All right, so again, if we're using the same picture, except for now we have the person who is 4 foot 9 inches, and we're looking for the shadow. So I'm going to call this X. And then we have the chair, which we just found out is 114 inches tall, and the shadow of the chair is 72 inches. And again, I got that from up above. So we're going to do chair over person again. So the chair's shadow is 72 inches. The person's shadow we're going to call X because we're looking for it. So 72 over X. The height of the chair we found out was 114. And the height of the person is 4 foot 9. 4 feet is equal to 48 inches. So this would be 48 plus 9 is 57 inches. So the person is 57 inches. So the 57 inches goes with the 114. So again, we're setting up a proportion for these two triangles. because similar triangles have sides that are proportional. So if we cross multiply, we would get 114 times x equals 72 times 57. So 114x equals 72 times 57 is 4,104. And then we divide by 114. So x equals 36 inches. So how long is the shadow for someone who is 4'9"? It will be 36 inches long. All right, so that will be angle-angle similarity. And once we find out the triangles are similar, we can do proportions to find side lengths.